Welcome to ScyllaDB Summit 2024. Scylla leaps forward this time. Actually, it's almost every year, but this year we really have something special. Thanks for joining. We're super excited, and the team plus multiple customers and users are excited to share their story. So I hope many of you know me by now, but I love tech. I love the outdoor too. Like in short, I can say that I love to shred and love to shard as well. So that's me. And I can say that why are we here? Primarily because Avi and I, when Avi came up with the KVM hypervisor idea 19 years ago, we've met long, long ago. And through that journey, we had three interesting learnings that we adopted. So, number one is layers are overhead. So, try to remove layers, and Scylla definitely removed layers. And it's interesting, and I encourage you to read the docs and see where we remove layers. And it's not just the JVM layer that we remove, it's also hops and other layers. We're kind of very excited about that. Um, locking is evil. Scylla is shared nothing and sharded, so we just don't lock. Simplicity matters. That's kind of obvious, but there are frameworks, and even KVM was one that keep on adding additional flags and more complexity. And it's not just enough to be fast and good. It's important to be simple, and things should just be the default settings. Otherwise, they're hardly getting used or it's too complicated. Um, Number four is million operation is a granularity that we expect the server to have. This is why we figured that there is a room for another database because existing database extremely struggled with a million ops, and neither KVM or Scylla think that's a problem. And number five, you see that I managed to um, have more learnings than the three that I promised you. So beware of one-offs or two-offs. Thanks for all of our customers who help us to be where we are. Scylla is graded for users and for customers. It's not just technology that we create for our fun, although it's fun even without users. But users make it completely a different ball game, especially these type of users and customers that of apps that we use every day. So we cherish the usage. We don't take it for granted, and the feedback is extremely important, especially now where we got to a place where we like to add additional features and also test new features and get your feedback. And you'll hear many of our customers here in this 2-day event. Make sure that you listen to their journey, and they help us to be where we are. Why ScyllaDB? I try not to market and to sell you Scylla that much, but most of you are new to Scylla. We have fantastic audience tonight, and it's a night here, and in one sentence, Scylla gives you the power of Cassandra at the speed of Redis with the usability of DynamoDB. It was kind of from the very beginning giving you the performance of Redis with the power of Cassandra, but in the recent years, especially nowadays, we bring you way better usability. The performance, leading the performance was there from almost the beginning. Availability was there. We run on multiple regions, multiple zones, multiple replicas, as many as you like. And scalability is great. And I'll demonstrate scaling up and scaling out is also outstanding. And things are automatically tuned for simplicity, and we're keep on improving Scylla with removing complex operations, and we'll cover it later. Compatibility is there with Cassandra and DynamoDB. It's also part of the no locking. Can run everywhere. You can also even migrate to another database if for some reason we didn't satisfy you. And we're open source. So the agenda of my session is twofold. The first is to just touch a bit on the architecture, and we have a long presentation about the architecture and multiple other features in many other sessions. It's just a glimpse, a couple of new results we have, and news brief about Scylla Cloud. It has lots of goodies in it and a dedicated session on its own. And the second part is introduction of Scylla 6.0 and tablets and what's coming afterwards. So let's dive in for the first part. So we talked about sharding. Scylla is sharded. All of our threads are pinned. The memories of every thread is pinned as well. And every thread is doing its own I.O. So we have a perfect shared nothing architecture that works really well and sets us up to a great success. Um, Beyond sharding, all of the nodes are homogeneous, and we have a ring architecture to divide and to shard between the multiple nodes. So there are two levels sharding, one of the cluster and one for each node. However, the ring architecture may not be with us for long because it changes in 6.0. That's kind of a preview for what's coming. And how good we scale. So always need to test that in practice. We tested it in the past in 2018, and just recently, a couple of months ago, we tested it again to see if we managed to keep up with the recent hardware generation. So if you run Scylla and you load it, and it's important to load it until it can't cope with the load, until it's bottlenecked, and then you discover that you need to scale either up or out, depending on what you like. So if you do it, you'll discover that Scylla can get to 100% CPU for every core on your system. Really nice, the top view in Linux. And we can run on small machines or many small machines or fewer large machines. Uh, Normally, we're going to recommend you to first fulfill your availability and disaster recovery needs, have as many machines as you like and spread them among racks or zones. But then if you got to this number, let's say 3 zones and 3 machines in every zone or so, then you can just, instead of having 90 machines in your cluster, you can have 9 large machines. And it's beneficial. It's easier to maintain. There are no noisy neighbors. And also, one important factor, the time between failures of the hardware is constant for small machines and large machines. Um, so the fewer machines you'll have less failures. Recently, we competed with a Google Spanner on a customer workload. It's a relatively weird competition because there are two different databases. But Spanner somehow they work with a tiny machines, so they needed 600 machines to run a workload that ran on Scylla with 10 machines. And the problem is that 600 machines probably have a failure once a day or so. 600, imagine, it's not that common. Now, even though Spanner is fantastic software and it's also a service, so you won't be the one who runs and to fulfill that machine failure. Think about how much potential downtime of a single failure you're going to have. If the hardware will fail and the other 599 machines will fail another time, then you're exposed to secondary failure that will lead to availability problem. So fewer machines is good. So let's see if we scale. And my colleague Felipe, and you'll see him all the time, helped me to run this benchmark. And in this benchmark, we took 3 machines of small, 3 machines, 4 vCPUs each, and loaded them with 1 billion keys. And it took 4 hours to load these small machines with a billion keys. And then we repeated the test with twice the amount of keys, 2 billion keys, and we still used 3 machines, but much larger machines, 8 vCPU machines, double the size and double the volume. And it took the same amount of time because the machines just scale linearly, Scylla scale linearly. So we kept on doing it, and let's see where we're going to stop. So we moved to 16 vCPU machines, still took 4 hours. We moved to 32 vCPU machines, still took 4 hours. Same with 64, and also with 128 vCPU machines. This is where the hardware surrendered. This is eye for eye metal machine. So this linear scale worked nicely. If you remember, we have a white paper of scale up before you scale out. And 5 years ago, we ran the same test. It worked nicely, but it took 14 hours. And today's code takes 4 hours. So nice improvement, both of the hardware and the software together. And the software is also comes with great observability option. Here is the Scylla monitor, and every shard is doing here in this benchmark 18,000 operation per second per shard. Its latency is 2 milliseconds for the P99 percentile. That's also nice. Now, the smart ones among you will say, hey, performance is nice, but what happens on failure? Would the large machine with a lot of data will take a long time to load? And normally that's correct. But we also have CPU scheduler and IO scheduler that make sure to utilize all of the machine also when we add machines, when we remove machines, and when we do other administrative operations. So we repeated the same test while we removed machines and replaced machines, and this measures how much time it takes for every cluster size to remove a node. And you see it's fairly constant, about 30 minutes. How much time it takes the dark blue to add a node, pretty much a similar constant amount of time. And lastly, how much does it take to remove a node while you have a write-heavy operation that exhausts the machine resources in parallel? It took pretty much same amount of time with an exception on the two largest types. We believe that it was a client issue, but as you see, the architecture of Scylla 6.0 is different, so we're going to retest it on the new architecture. So that's about scaling. We have news to show. So the first is it's a new year, and we have a new enterprise release. Our releases are named by every year. So 2024 release implemented profile guided compilation, which is an amazing optimization. 2024 enterprise release is based on the 5.4 open source release, and it's almost the same code base with small changes, mostly around security and enterprise features. But in terms of performance, this one big profile guided optimization brought something like 25 to 45% improvement. And it's something that we keep for our paying customers. I'm sorry, we need to hire more developers to make Scylla better. So that's exciting. Open source itself is fabulous as well. And speaking about benchmarks, Scylla is a columnar database, and we compared ourselves with many columnar databases in the past. Let's see how we do against the lead document database, MongoDB. So we benchmarked Scylla versus Mongo. It's actually not us, but Benched Ant, a third-party independent company. And you can guess that Scylla turned out better. Our performance were even surprised us in this case. We compared both throughput of small deployments, medium deployments, large deployments, latency, while we compared the throughput and everything else. And this shows the gain in percent that every case had compared to MongoDB. You can see that we highly score, and we have detailed results in the blog. So I won't going to cover all of them. And we have a customer presentation about transition from MongoDB to ScyllaDB. So this is just a glimpse, but in general, it was a really fair benchmark uh, done by a fair, great third party. It's SaaS, so no server installation, no configuration, just out of the box. It's fair for both databases. Standard client, YCSB, no modification. We won almost all of the workloads. In one, the latency was slightly below while we performed better. Perf- Performance was 10 to 20x better, and altogether latency was also 10 to 20x better. Uh, and we scale better. So in this test, it's demonstrated that what's the performance of a small cluster of Scylla, and if you increase its resources for X time, how it performs in actual, and it's supposed to be 400% better. We got to 387% better. It's pretty much similar. With MongoDB, it wasn't the case. So not only MongoDB small deployment isn't efficient as the Scylla deployment, but also it doesn't scale. It's only halfway of its potential scaling size. Now, it's probably not a surprise. MongoDB is an amazing database for early workloads, for experimentation, but when it comes to scale, better use more efficient and more performing database. Um, Cloud. So Scylla Cloud today have 65% of our customers, and most of our revenue comes from Scylla Cloud. It's a common trend. It's a win-win for us. It's easier to manage. It's also safer because we run all of our ops and automation in it, and it's easier for you as a user just to give this complicated distributed database to someone else to make sure that not just it doesn't just runs well, but also when there is a disaster or when you need to do backup and recovery at weird hours in a holiday, someone will do it for you. And we've made lots of progress over the past years. We added Terraform provider, extended the APIs of self service, especially around management and scalability, self-service. Uh, many networking modes from multiple zones to multiple zones and client aware, zone aware, so it will save you the traffic. We're adding a stream compression to also to reduce the cost of networking now. We have single zone, we have transit gateway, and we have shared VPC. So multiple networking mode. Encryption at rest is the default, and bring your own key is optional. We were certified with the SOC 2 and ISO, and PCI is 2 months away, and Azure will be introduced towards the end of this year. So lots of things going, and Michael, the Scylla Cloud product manager, will present all of these in a detailed presentation. Now let's go to Scylla 6. So we have major news coming with open source version Scylla 6.0. It's basically, we can say that we got to from eventual consistency to immediate consistency. And we're very happy about it because Scylla today, prior to 6.0, is great, but it's not perfect because topology changes, adding and remove node removal are only allowed once in a time at a time, and also you have to wait 30 seconds between them to make sure that there are no timeout and it's consistent. It's not classical. If you want to double the cluster, then it will take you some time. If you need to scale and you lose a node, you first need to heal that node, and only then you need to scale. Can't do it in parallel. It's makes your life complicated. And also streaming, when you send data to add a node to scale, we process the data based on the schema. We do it row by row. And if you have a good, like an easy schema, not necessarily good or bad, but schema, let's say with large objects of a kilobyte, it's not a problem. But if you have tiny fields in it, like 100 bytes per row, then streaming time will grow linearly, and it can take a long while. And lastly, there are other operations like cleanup and repair that make your life complicated. So we wanted to solve this. And this is solved by a consistent schema changes that was introduced already to Scylla and is part of Scylla 5.2 together with Raft, by topology changes, and by tablets. Before I'm going to provide more demonstration about the implementation, let's talk about the values. So these things will allow us to be more elastic, to boot in parallel, to add nodes in parallel, to double a cluster in parallel, and to serve requests immediately when a node joins a cluster. Streaming will be way faster than what it used to be. We're going to load balance thing. I'm going to present it. Things are will way simpler. Some actions will be completely transparent. And the TCO is better because you'll need less free space in your drives. Today, the recommendation is around 30%, depending on the compaction algorithm, and it can be reduced with tablets to something like 10%. And also, once everything is more elastic, you do not need to over provision for an emergency. You can just ignite more nodes and then keep a smaller deployment on a regular basis. So what's under the scene? Under the scene, we have Raft. That's a distributed protocol for a state machine replication. So this is under the hood. And Raft makes sure that schema changes will be linearized and consistent. And also the token metadata, the one that is responsible for sharding the token ranges into nodes, is also linearized. So we can add nodes in parallel and allocate these metadata tokens into more nodes in parallel. And we issue barriers between every topology change, and these barriers are safe. And not only that the metadata is safe, the control plane, we also made the data plane more safe by adding fencing. So if, let's say, you start an operation and think about it, you have multiple replicas within a region and multiple other regions. If you start an operation and then you change the topology, you want to make sure that that operation that started needs to have the same version of the control plane when it arrived to the target node. So we have a process that calls fencing to make sure that every such topology change or metadata change is versioned, and the versions should not commit into the wrong era. Altogether, we're going to also have a Raft session, but altogether, all of the efforts that we've done over multiple years will come into play in Scylla 6.0 with topology changes and schema changes and consistent tables. Our system tables are already Raft based and have immediate consistency, unlike eventual consistency in the past, and the tablets. So speaking of tablets, let's give some tablets demonstration. Prior to tablets, we had nodes and virtual nodes, vnodes, and keys used to go, and the client was topology aware. So the client already knew which node to access, a node that owns the key range. and the keys are distributed with a nice load distributed. Hopefully, your schema and your keys are managed to cover the entire key range fairly, and this is the way it works today. With Raft, we do not have these static V ranges as we had with V nodes. We basically form groups. Each Raft group is a tablet, and tablets is a form of about 5 GB of data. And this is the way we allocate data, and the way we shard, and the way we map tablets into particular nodes and particular shards within those nodes. And the clients can either be standard ones without knowing anything about Raft or tablets, and will just find a random coordinator within the group, or they can be topology aware and tablet aware and send the data directly where it needs to be. We support balancing, and a regular table starts with really few tablets because we believe that we can have hundreds of tables in a cluster, so no need to divide the metadata to every shard in the system. So table starts with a small amount of tablets, and over time, as you add more data, those tablets get splitted and get balanced as the data grows, and also it can shrink the other way around. And usually the tablet split is by disk, but can also be over time with CPU. CPU is not implemented yet. So tablets can be split and can be sent to another shard within the same server or within another machine. In this way, we can load balance and also gain all of the fault tolerance that we need. Besides load balancing, we can do resharding and modify on the fly a server type, and you can move from a large machine to a small machine, and the opposite. Every tablet, all of the files within every tablet are regular SS tables, just smaller ones than what we used to have before. So we just need to either separate and compact SS table to multiple smaller ones, or to compact multiple files into one bigger SS table file. Now, cleanup operation is trivial. Cleanup is when a node contributes a range to some other node, then those files need to be deleted on the original server, because all of those files that were contributed belong to the same tablet. Basically, we just remove that file. That's it. What we do today, we need to really run full compaction, because there is a mix of ranges of the range is split, but the SS tables aren't, and we need to compact it. With tablets, there's no need to compact, just need to delete the file. So cleanup is trivial, and is also done automatic by Scylla for you, and you do not need to know anything about cleanup. There is a tablet scheduler that makes sure that all of the node operation are done in a scheduled manner. So if you run repair, for example, tablet that undergoes repair won't be migrated while repair is running. So that's the scheduler responsibility. It's something completely internal. You do not need to know about it. The scheduler is smart, and if you add 2 nodes, automatically the scheduler will strive to load balance all of the capacity of tablets within your nodes. And it does it not completely all together, but it does it in a groups of several tablets at a time. Repair is also considerably simple. Repair is like a fire and forget, because it's tablet based. It's not node based or cluster based. It's tablet by tablet, and the scheduler is responsible for repair. It's also continuous, and we have this automatic GC grace period. So every time we repair, we automatically no need to wait for a timer like in the past. We automatically delete the tombstones, and repair is complete. So also data uh, is not saved. Tombstone data is not saved for a long time. So repair is simplest as it ever been. And as I uh, alluded before, streaming is faster because we stream and we send SSAbles and not row by row. And we measured 30% gain. It's a gain that we reserved for Scylla Enterprise. But everything else will be faster as well. So all of this comes in Scylla 6.0. Scylla 6.0 now awaits for the master branch to stabilize. It's feature complete. We just need to and CI is working, but there's plenty of other tests that we need to flush, and then we're going to branch 6.0. Lastly, and we near the end of the presentation, there are more things that come beyond 6.0, and we just started this year. So tablets will allow us to be serverless. And previously we kind of played with Kubernetes and VMs, but here we talk about pure serverless in the concept, because we have fast streaming and parallel operation, and all of the unit sizes are small, so there's no big effect on performance when we move tablets around. And once you add resources, you immediately start serving. So it makes us independent on the cluster size and the instance size and the instance type. So everything is pretty dynamic. So imagine these use cases. Either on the left, you can be typeless. No need to think about ahead of time, will I use very volume-based, like i3en type of instance with a lot of volume? Will I be a lot of throughput-based, like i4i machines? Because the volume may vary over time. We can automatically adjust it without you getting married with the type. The same about size. No need to do too much capacity planning. You can start small and change it. You can start high and reduce it. And you can commit to a base and have on-demand usage above it. So with 6.0, things will be very, very dynamic. Besides tablets, my probably last slide for today, we have more things going on. We have full transactional consistency with RAF. Today, the metadata enjoys it, system tables enjoyed it, but we like to bring it to the rest of the other tables and to the normal data tables, and to have it optional. So it's in the works. We're working on denser nodes. Some of them are HDD based, and we like to break the ratio between memory and disk and make it more consumable if you need to have a large volume deployment. We have S3 working, but it's not productized yet. We're working on it, and we work on a bunch of other improvements in the future. There's plenty of things to do. No rest for the weary in Scylla. So if you survive until here, there's plenty of interesting sessions for you. Thanks for listening, and thanks for innovating, and thanks for bringing all of these fabulous use cases to Scylla. Have a great rest of the day, and thank you. I'll be around. Bye-bye.